Hello everyone. So in this numerical problem, what they have asked is use source mobility to reduce the network shown and also to find the value of AX. So the first thing for you to do is identify the sources. What are the sources? I have a current source here and then voltage source here. So current source is connected between two nodes. So when you're doing the source shifting, you have to connect in this manner. Okay, so the current source will come like this. First 5 ampere from this node to this, and one more 5 ampere from here to here. That is the first source shifting. What can I do with this voltage source? Either voltage source should be shifted here across this node, or maybe across this, whichever is easy for you. Okay, so what I will do, I will shift this voltage source to this point and to this point. Please do understand. Okay. So let us rewrite the circuit after doing the source shifting for both the cases. You can do step by step, or you can do like me together. Okay. So I will leave some space for the voltage source here. So first, what I will do, I'll do source shifting for the current source. Okay. I'll write the direction later on. Next, here I will do the source shifting for voltage source. I will do all these connections first. There was a current source connected from here to here. Now I have done the source shifting, so I will not be connecting any wire. Okay. And what is the direction of current source? 5 ampere upwards from here to here. Correct? It was like this. Direction was like this. So it has to be in the same direction, even if you take 2 source shifting or 3 source shifting. Okay, so done. Let me write this also. I should not be forgetting later. Plus minus Vx. So this is your 7 ohm. This is your 3. Okay, so this 7 ohm resistance was positive with respect to voltage source. 3 was also positive with respect to voltage source. So when you're connecting the directions, sorry, when you're noting down the direction, it should be like this. 3 ohm positive with respect to voltage source, and then 7 resistance. It should also be positive with respect to voltage source. And what to do with the this particular point? It has to be connected with the wire. That one you have to understand. Don't leave this part. Okay. So now 6 ohm and then 4 ohm. So now you see we have done source shifting for this current source as well as voltage source. And what do I mention always? Usually the sequence of events will be first source shifting and then source transformation. Usually it will follow the same. Okay. You can do the same thing here as well. Since I forgot to write the value, I'll write here. Now what should I do? I'll do the source shifting, sorry, source transformation for this 3 and the 5 ampere. So 5 into 3, 15. Arrow mark is in this manner. So where is the arrowhead? There comes plus and then minus. This is when I do the source transformation. So let me rewrite the circuit very fast. So I have a 3 ohm and then 3 into 15, it will be 15 volt. And then I have a 7 ohm. There was a voltage source, again a voltage source, and then a resistance. And this one also I can shift, right? No, I can do the source transformation. So I will do the source transformation here as well. So here there was a wire connected. Let me go back to check. 4. And then here it was 6. Correct? This one, how did I write? Minus plus, plus minus. This is 15. This is 15. This one was 3. 3. And here 6 into 5, 30. Okay. So this is 30. This is 6. And one more resistance was present. It is 18 plus minus Vx. Okay. One thing to note down here is, see, this is plus 15 and this is minus 15. So even if you apply KVL or just find the algebraic sum of potential difference, here it comes 0. So what you can do, you can just replace it with a simple wire, and then 3 and 7 are in series. So I will make them 13. Okay. Similar way, here this 15 and 3, I would like to convert or transform it into a current source and a resistance. So let me do that. Let me write this one carefully. Plus minus. This 6 and this 4 are in series. So let me write it as 10. And then again I have a 10 here, 3 and 7, 10 ohm. This is the 18 ohm plus minus Vx. Next, I have 3 ohm. So I told you I will be doing source transformation for this one. So 15 by 3, it is 5. And the direction you see, plus was to the right side. So direction of current will be this. So 5 ampere. And what else is left out? There was a wire. And then left out is 6. Okay. So now what you can do? These 3 and 6 are in parallel. So you can find the parallel resistance for 3 and 6. Okay. So I will write it here. First I have 18. And then again, I guess I can transform this one also again to parallel. Okay. So I have a 10 here. Current source. If I am doing in this manner, let me write the current source. So the direction was plus minus. So here also same thing. This was how much? This was 10. And then here comes 3 and 6 parallel equivalence of 3 and 6 is 2. So I will write 2 ohm directly. And then what else was left out? This 5 ampere. Okay, so this 5 ampere. Now what I'll do, I'll take the equivalence for this 10 and 10. Sorry, I forgot to write the current. Current was 30 by 10. So here it will be 3 ampere. We will rewrite the circuit. So this resistance will be 10 and 10. So 5 and one current source in this manner. And this resistance is 2. Anyhow, I can do source transformation, right? So we'll do source transformation. 2 into 5, 10. So direction is minus plus. Similar way, I will do source transformation for this as well.
Okay, so here what did we do? Parallel equivalence of 10 and 10, it will be 5, right? So that's what we have written. Why did we write 10 here? This is 3 ampere. So 3 into 5, it will be 15, not 50. Okay, so now what do I have? We have one 18 ohm, 7 ohm, 2 ohm, and then two voltage sources 15 and 10. But you see, 15 is plus minus, 10 is minus plus, right? So I can add these two since they are in series. 15 minus 10, it will be 5 volt. Okay, so I will rewrite the circuit. So the circuit will be 18, 15 minus 5. So 10, and then what else was there? 7 was there, 2. So 7 plus 2, it is 9 ohm. You are supposed to find Vx here. This is how much? This was 15 minus 10. So it was 5 volt. Correct? So I have simply written one I so that I can find I across this resistance. I into 18 will be Vx. So in order to find I, what I can do, I can apply the KVL, right? So loop in this manner, 5 minus 18i minus 9i equal to 0, I will be equal to 5 by 27. So Vx will be equal to 5 by 27 into 18. 9 2s are 9 3s are. So it will be somewhere around 10 by 3 or 3.33, I guess. Correct? Let me check once. 10 by 3. Correct. Okay, this is how you solve this numerical.